Okay, projectile motion. Now, you guys probably have seen this many, many times before. Physics, extension 1. Now, in extension 2, we do look at some similar kind of extension 1 projectile motion. So, just to start you off, there is projectile motion without resistance. And then I'll see how much projectile motion with resistance I can show you today. But I thought I'd just get you back in that mindset of projectile motion and how it all kind of works with these different components. Typically, we look at a few different types of problems. So the main types of problems that we're going to look at, we're going to look at finding the maximum height of our projectile. We're going to look at time of flight. And we're going to look at range of flight. So hopefully these are things you've kind of thought about or seen before. How would we find some of these things here? Like the maximum height, we know that occurs when, what? When V is equal. And so remember, if we're breaking it up into our horizontal and vertical components, we're looking for the velocity or the vertical velocity to be equal to 0, right? So the maximum height occurs at that point. But if you're looking for the maximum height, we're also actually looking for y. So you kind of have to do a bit of linking here, right? You have to let the vertical velocity be 0. You have to find when that kind of occurs, and then you're looking for what is the actual maximum height. So that would be your y value there, right? Time of flight, similar kind of idea, right? So time of flight, well, that's how long this thing takes to reach the ground again, right? So what are you actually looking for there? You're looking for a t value, okay? But then when is this particle, like how do you know when the journey's ended if we're looking for the time of flight, if you think about it? If it looks like this, right? So let's say sides here, how do we know when it ends, basically? Sorry? When it hits the ground, and that's when, what? When your y value is equal to 0 as well, right? Can you think about that way? Like, if you think about, well, yeah, it depends on the situation. So typically, yeah, that's right. So if there is a modified situation where it's on a cliff or something like that, that may affect it, but that's the kind of idea that we're looking for. And then the range of flight, again, we're just thinking about the different things we're looking for. This time, the range, I'm looking for that. Right, so that's the range of flight. So when this guy is going to hit the ground again, so I want to know when x equals to 0. Oh, sorry, not when x equals to 0. I'm looking for the x value when y is equal to 0. Sorry, yeah. Does that kind of make sense, like the differences between those? Like what you're actually looking for and how you might go about finding those things. The other thing I want to distinguish between is something called the parametric and Cartesian. So in year 11, you looked at very briefly the concept of a parametric equation. And the parametric equation is like, there's like a hidden parameter, right? There's something that's going on behind the scenes. Basically, it's like a third variable which links both of them together. And in this kind of situation, when we look at motion, it's usually time, t, right? But Cartesian, that's what you've been dealing with normally. That's in terms of x and y, right? So if you want to find a Cartesian equation from a parametric, it's basically solving a set of simultaneous equations. So I'll give you an example. So if you have these parametric equations here, let's go ahead and convert these parametric equations, which are in terms of t, into Cartesian equations. So yeah, like I said, it's just a matter of solving a simultaneous equation, right? So we'll rearrange for t as the subject here. And then, okay, I've got something in terms of t. I'm going to go ahead and solve for y here. solve for y. I'm going to rewrite y in terms of your x's, okay? So a lot of the skills that I'm going to introduce you first are going to be heavily based on extension 1 skills, because this sort of topic, projectile motion without resistance, in this form was actually in the old extension 1 course, actually. So yeah. So this in Maths in Focus is 7.03. So that's, I'm going to write it up here for you to remember that. We'll look at that a bit later. In Cambridge, they kind of mash the projectile motion without resistance and with resistance together. But I recommend you start with this one first, because it's a little bit easier when you don't have to consider the resistance components, right? What did you have for this one, Matt? Yep.
Plus 2x. Oh.
Yeah, oh, you can just simplify. What did you get? Okay, cool.
2x.
Yeah, that's fine.
10, 3.
Yep.
Minus 5x squared on top.
Yep.
With 100 times
300, yep. If you square both insides. And then you can go and simplify. What's that? X on 5 root 3 minus 5x squared on 300. Now, if you are really good, what might you do with this guy here? Yeah, you might want to rationalize that one. So that would be like root 3x on 15 minus, and then that's x squared on 60 when you simplify. Right. I just did it just then. So, that's converting between Cartesian and parametric. So that's something that they might get you to do. And they kind of both have their benefits depending on the situation you're doing. The other thing I want to mention is that these equations here, these refer to the horizontal and vertical displacement. So where exactly the particle is horizontally and vertically at a given time. But these equations, they do often give to you, but you are often required to derive them. So I'm only going to derive them once here for you, because it's a similar way, and I want you to, like the skill is just essentially integration, and you've done it before in extension 1, but just to refresh your memory, I'll go through it. But then from then on, I won't really derive them after that. Yeah.